I think everybody knows that string inverters are easier, simplified O&M. Spare parts list, we say it's fans, but really we just advise having a handful or so spares on site because, again, you have a central inverter fail, catastrophic downtime. That 4 megawatt block is down. There's hundreds of spare parts that you have to have in inventory, and can be a supply chain constraint that the industry has seen before that can lead to prolonged downtime. And then you're additionally at the mercy of a specialized technician to perform the repair. Whereas string inverters, it's technician level O&M, and it's a swap. And we're talking less than an hour to replace that 350 kilowatt inverter. It's even less time than that for some of our other products.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility, solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 8 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Today on the Clean Power Hour, we continue the journey. The transition from central to string inverters is real and prescient and happening in the U.S., and for good reason. My guest today is Luke Schlichte. He is the utility sales rep for CPS America, otherwise known as Chint Power Systems. Welcome to the show, Luke.
Hey, thanks for having me, Tim. Always great to talk to you.
I love this topic. I just think of central inverters as outdated buses. Like, they're just ginormous. It takes a huge crane to move these things around. And there was a day when they were the standard, but things have changed. And across the globe, we forget, Luke, that the United States is not at the forefront of solar technology and design and construction. Unfortunately, I wish we were, but we're 10 years behind Asia and Europe. And one of the major trends in solar construction is this adoption of string inverters for utility solar. These are 100 megawatt projects to gigawatt now. We have some 1.2 plus gigawatt size utility solar projects. These are really big. These are tens of thousands of acre solar farms. So anyway, Luke, give our listeners a little background on yourself and how you came to the utility sales role at CPS.
Yeah, thanks, Tim. Yeah, so I've been with CPS for almost 3 years now. I've largely been in sustainability in my career. But yeah, I had a good friend of mine refer me to CPS, and it's been an incredible ride. You obviously know about the team and the culture, the leadership we have here. I've been very fortunate to be a part of the team, and I was really drawn to our utility products, our high-powered string inverters. They're obviously the best spec on the market, but really what interests me is there's a really big underperformance problem with utility scale solar in the US, where that's really taking a toll on the production and revenue for these long-term asset owners. And really, I think string inverters, modularity, and specifically CPS's solutions are the remedy there.
Yeah. And it's a simple trade-off that gets made. If you're an asset owner, this is of particular interest to you because, yeah, on the front end, designing in central inverters might be a little cheaper still today in 2025, but the long-term project cost, the OpEx, is going to be lower with string inverters. And it's not rocket science, right? Because when you lose a block, when you lose a central inverter, let's say a 5 or 10 megawatt inverter, right? That's a huge chunk of revenue. kWh is revenue, right? Whereas with a string inverter, in the string space, we're looking at 350, maybe 375. Do you have a 375 yet?
350, that's our biggest one, and the highest power string inverter on the market in the world.
Yep. So the 350 kW, yeah, it's like a small refrigerator, but two workers could carry that device. You can have spares on site in the trailer, in the container. There's just a lot of practicalities to having string inverters. I'm curious though, Luke, you're talking to customers day in and day out. What are some of the conversations you're having, and what is it that customers like about 350 kW string inverters?
Yeah, getting back to the underperformance issue, if you are the long-term asset owner, you have skin in the game, or you're using private equity and you're not hitting those production projections, then you're concerned about how you can relegate that and fix that. And to me, it's clear, it's modularity. And I think we're best positioned to kind of lead the transition from central to string. Obviously, it's the status quo. We have a very CapEx focused system here, and obviously a lot of pre-existing relationships. So you just keep doing what you're doing, but there's a better way now. I know I get from a lot of people that, hey, we've done this exercise 100 times where we do string versus central. I guarantee that they haven't done it with a high power string inverter that's 350 kilowatts. They might have done it before when they're talking about 50 or even 100 kilowatts, but the math is different now. And there's so many different ways that string addresses all the underperformance problems, not just at the inverter, but on the string level, combiner, and tracker level, which are all the main downtime causes with the utility scale power plant.
And one of the key decisions, I think, in solar plant design that gets made is, are you going to do a distributed or a skidded approach? Distributed, and this is an advantage and an option with string inverters, right? You can literally sprinkle the inverters out throughout the solar field, typically at the end of rows, but depends on the design. Or you can do a central version of that where you bring all the inverters to a skid, and it's apples and oranges. But what do you have to say about that distributed versus skidded design approach?
Yeah, absolutely. The distributed, I think, has a lot of advantages, and I like to say that there's no flat rectangles left anymore for the utility scale projects. So you're going to have weird shaped parcels, you're going to have topography challenges, and that's really where I think the distributed approach can be advantageous. Similarly, we have a lot of EPC partners that want to be able to have that centralized approach to mimic a central inverter, but then have the benefits on the backside of the ease of O&M, the swappability of string inverters. They want to have those benefits. So I'd say our skidded string product was born out of the feedback and the want from our EPC partners that maybe they're participating in a RFP that's calling for central inverters. Now we can mimic that with our skidded string. You can still collect all your DC in the field, use your trunk cable or your Shoals VLA, and then have that single input with our skidded string and be able to have that benefit time there. So you're taking away that risk of catastrophic downtime that you have with a single point of failure in a central inverter.
Yeah, we're going to see that theme time and time again. Catastrophic downtime avoided. That is the key phrase. What about, let's talk a little more about the financial impact of string inverters versus central inverters. In our previous conversation, you referenced a report from Raptor Maps, but what do you say to customers about this regarding the financial impact of string versus central?
Yeah, I would say a lot of folks that I talk to, when I talk to them about our solutions that were specifically designed for the utility scale part of our industry, that are string inverters, their interest is piqued because they've already been pulling their hair out with some of the issues surrounding central inverters, whether it is, we talked about that risk of catastrophic downtime. They've lived that catastrophic downtime, and it's sometimes been weeks, months. I've heard 6 months or longer. I've heard of 200 megawatt projects that had 14% uptime after a year. Really, they're already looking for solutions. Really, it's the first question is on the capex, like you mentioned. We're right there. We're on par or close to with central inverters now from an equipment perspective. There are some learning curves that I hear about when you're designing with a string versus central, which our applications engineering team will work as an extension of their engineering team to help dial in the design side, to help with string sizing, design optimization. We're here as a resource, and as we view ourselves as a partner for the life of these projects. So not only on that front end, but that service is one of the main reasons why we've been able to have the kind of customer retention that we've had for and enjoyed that number one spot for market share with three-phase string. Really, the modular approach combined with the backstop of the best service in the industry, that's how we're going to ensure that your production estimates are going to be attainable.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 8 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. I did some quick math, and we have a 5 megawatt project on campus here in Central Illinois in Champaign, where I live, and it has central inverters. But I did some quick math on a 5 megawatt inverter. Okay, roughly speaking, for fixed tilt, which it's no longer, it's tracker now, but for fixed tilt, that a 5 megawatt inverter is producing 500 megawatt hours per month. It's a lot of juice. And this translates into, of course, savings for those PPA customers that are buying the power, and it translates into revenue for the IPP, the asset owner. And when both of those go away, you're just looking at a hole in the ground, basically. It's really a pain point. And in this case, the inverter was down for months because they couldn't get a replacement part. And so it wasn't just 1 month, it was like 4 months of downtime. Oh, yeah. And you, as an asset owner, as an off-taker, you're just not happy about that. It's just really painful. So I do think that's just a no-nonsense way to explain this to people.
Absolutely. And to that, CPS President Brian Wagner, he likes to refer to the inverter as an ATM. If your ATM's not working, it's not pumping out cash. When people talk about CapEx, I try to turn the conversation to production, because the #1 goal of building a power plant should be production and uptime. Production is king for everything that we do. I really think the more, as we go, more and more projects are going to be going with string inverters just because they're going to make them more profitable.
I wonder if, for our listeners who are not that familiar with large string inverters, what are some of the innovations that CPS is making to improve performance, reliability, serviceability, and cost in this space?
Yeah, absolutely. Great question. You've been to our headquarters in Richardson, Texas. In our headquarters there, we have our CPS labs. And as far as I know, we are the only inverter manufacturer that takes our RM8 inverters from our customers and we study them. We try to find out what went wrong and what we learn in the lab there. We're building solutions to be included in products going forward. A lot of innovations that we've led with in the industry, one of them being DC enhanced, that came from some of that work in CPS labs. To that, we're constantly getting feedback, and we're receptive to feedback from our clients because we want to listen to the market. I would say, again, the 350 kilowatt inverter, that is the highest power inverter, string inverter in the world. It full power, full 350 kilowatts of power up to 45 C before it begins to thermally derate. That's a higher, I guess, the derate number than our competitors with a similar sized string inverter. So that's something that's going to ensure that uptime. 15 MPPTs per 350. So for a 4.2 megawatt block, that would be 12 350 kilowatt inverters times 15 MPPTs. You're talking about hundreds of MPPTs per 4 megawatt block. That's advantageous not only to reduce mismatch losses, but also now you have granularity in your data down to the MPPT level. When there is it might not be a failure in the inverter, it might be a failure on the string, combiner, or tracker level. You're able to identify where the issue is much faster having that kind of information. It's not a needle in a haystack what it would be with a central inverter, and you have one or maybe 4 max MPPTs on a similar size block.
Yeah, we have to remember there are other problems that happen with solar projects. It's not just inverters, but having string inverters can help you zero in on where the problem is. Good point. So in that regard, what are some of the maintenance and servicing differences between string and central inverters that our listeners should know?
Yeah, that is huge. And I think everybody knows that string inverters are easier, simplified O&M. Spare parts list, we say it's fans, but really we just advise having a handful or so spares on site because, again, you have a central inverter fail, catastrophic downtime. That 4 megawatt block is down. There's hundreds of spare parts that you have to have in inventory, and can be a supply chain constraint that the industry has seen before that can lead to prolonged downtime. And then you're additionally at the mercy of a specialized technician to perform the repair, whereas string inverters, it's technician level O&M, and it's a swap. And we're talking less than an hour to replace that 350 kilowatt inverter. It's even less time than that for some of our other products, but that spares on site, you can swap it in, technician level O&M, which I can't stress that enough, as I feel like the specialized technicians, they are already spread too thin. And these specialized technicians, it's $300-400 per hour. Now that all these huge utility scale projects of 2, 3, 4, 500 plus megawatts are becoming more and more commonplace, we're reading about every day. What's going to happen when they have failure issues and we have these specialized technicians that are already spread thin? They're going to become even more spread thin. And then we have labor issues with electricians and technicians, not just in the renewables industry, but everywhere. So I think we have a looming concern there, and string is going to be the remedy here.
In 2023, I wrote an article in PV Magazine about a Clenera project in, I think it's Beaverton County, Montana. It's called Apex Solar. It's a 105 megawatt DC solar project. Beaverhead County in southwestern Montana. And there's a great quote in here from Clenera's CEO. If you're not familiar with Clenera, check them out. They're a big global IPP. But CEO Jason Ellsworth says, the prolonged downtime for repair or replacement can be detrimental to project performance, referring to why they have switched to string inverters from central inverters. So check that article out. If you just Google Montague, Central to String, PV Magazine. You'll find that article, or reach out to me. Please check out all of our content, cleanpowerhour.com. Reach out to me on LinkedIn. Luke, what else should our listeners know about your work and how you work with customers? Would love to learn a little more of behind the scenes. What's it like working with Luke Schlichte, and what is your specialty? What is it that you're looking for, the conversations, the types of clients that you're wanting to attract?
Yeah, really. Hey, if you have skin in the game, if you're a long-term asset owner, IPP, we are going to ensure the most amount of uptime. We're going to make sure your P50 estimates are attainable. As I think I already said, we view ourselves as a partner for the life of your project. So we're going to be as invested in the performance of that project as you. So would love to see how we can fit in to make your project more profitable.
And how can our listeners find you, Luke?
I can be reached at luke.schlichte, that's SCHLICHTE, at chintpower.com. You can find me on LinkedIn and DM me.
Awesome. I want to thank Luke Schlichte, Head of Utility Sales for CPS America. Again, reach out to me on LinkedIn. I love hearing from my listeners. Tell a friend about the show. That's the best thing you can do to help the show. And with that, I'll say, let's grow solar and storage. Thank you so much, Luke.
Hey, let's raise the bar for utility scale solar.
All right.
Appreciate you, Tim.
Have a great day.
You too.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 8 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.